Right click on the desktop, create new folder, type inverter. We are doing inverter, CMOS inverter. Create. Now open inverter folder, right click, open in terminal. In the terminal type CSH source /home/install/CSHRC. Type Virtuoso. Now this is CIW window, command interpreter window. Right. Go to file, new library. We have to create our own library. For that type library name as inverter. Select here, attach existing library. Apply. Attach my library to GPDK 180. OK. Now OK. Now my library is created and attached to GPDK 180. Now new cell view. Here library, select your library. I type in INV. I created INV as a library. Select that library. Type cell name. Inverter. This one is user defined. Schematic. OK. This one is schematic editor window. Here go to create instance. Here from GPDK 180 library we have to take NMOS and PMOS. PMOS will change finger width. Take 40 micro for PMOS. Hide. Place PMOS. Same, take NMOS. NMOS from GPDK 180. Width 20 micro. Place below the PMOS. Now we have to connect NMOS and PMOS. W for wire. Type W. Connect gate to gate. And drain to drain. Here PMOS source is connected to VDD, NMOS connected to VSS, gate is connected to VIN, drain is output. For that we need pin. Create pin. Here we need 3 inputs: Vin, VDD, VSS. Direction is input. Hide. Place Vin, VDD and VSS. We want output pin, so pin Vout. Direction is output. Hide. Place. Now connect all these pins. That press W. W for wire. Connect. Now CMOS substrate is connected to VDD and NMOS substrate is connected to VSS. This one is CMOS inverter schematic. Save this schematic for now. Inverter schematic saved with no errors. Now we have to create symbol for this. So create cell view. From cell view, same, nothing change here. Now place the pins. I need V in as left pin. V out is right pin. Top pin is VDD. VSS is bottom pin. Okay. This is symbol. Now delete this inner box. For that press delete. We have to draw here inverter symbol. For that take create line. Now take circle and draw circle. This is inverter symbol. Now check and save. The CIW window. Symbol is saved with no errors. Now go to CIW window, Virtuoso window, File, New, Cell View, same library, inverter. We have to create Testbench for inverter _ EB. Change the cell name. Okay. This is inverter Testbench schematic editor window. Now we have to place that symbol in create instance, select library you have created, cell, inverter, symbol, ID, place. we have to give inputs for inverter. For that, create library, analog library. In that, VPulse. Select VPulse. Here voltage 1 is 0, voltage 2 is 1.8 volt, period is 20 nano, delay time no need to give or otherwise 2 nano, rise time 1 pico, fall time 1 pico, pulse width will take 50% duty cycle, so 10 nano. Hide. Place this VPulse in input side. Now we have to give VDD. For that, analog library, VDC. Here DC voltage is 1.8 volt. Hide. We have to place positive terminal to VDD. So rotate and place. Output. Capacitor. Capacitor is 0.1 picofarad. Hide. Place it in output side. Now take ground, analog library, ground. Hide. Place. Escape. Now connect all these points. For that, press W for wire. Name input and output wire. For that, press L. V in and V out. V in, V out. Save. Inverter Testbench is saved with no errors. launch ADEL window, analog design environment window. Here go to setup, model library, select this gpdk.scs, uncheck all this. Okay. Now we have to analyze a transient and DC output. So analyze, choose here transient 100 nano, moderate. Okay. Now again analyze, choose DC voltage, DC analysis. Here save DC operating point, check this, and component parameters, check. Now select input component DC voltage. For that select component, select input voltage V pulse. Here select DC voltage. Okay. Now start point is 0 and stop point is 1.8. Okay. We are doing transient and DC analysis. We have to select input and output. For that, outputs to be plotted, select from design, select input wire and output wire. Here. Now simulate netlist and run. This one is transient in analysis. And this is DC analysis. Now we have to calculate delay. Total propagation delay. For that, TPLH and TPHL, go to tools, calculator. Now check wave, uncheck clip. Here select delay function. Signal 1 is input signal. Signal 2 is output signal. And here threshold voltage is 0.75. Both signal 2 threshold voltage is 0.75. Edges 1, edge type rising edge, and this one is falling edge. This is TPHL. We are calculating TPHL. Okay. Now run the buffer. Now this delay time. This one is TPHL. Now for TPLH, calculate TPLH. Signal 1 is input, signal 2 is output, same 0.75 threshold voltages. Here falling edge and signal 2 is rising edge. Okay. Now run. This is TPHL and TPLH. Add both values and you will get total propagation delay. This one is inverter simulation. No? In ADL window, session, save state. Save the analysis and outputs. Okay. Now close this.